Alright, in this video we're going to be solving an exponential equation. We have an exponential expression on each side of the equation. We cannot get equal bases, and so we're going to have to try a different method here. The first two methods are going to take the exponential expression and rewrite it in its equivalent logarithmic form, and then we'll also do an example where we take the natural log of both sides. They'll all be kind of similar. Some may be a little bit more complicated than others. So here we're going to go ahead and we're going to rewrite, and if I have e to the y power is equal to x, that's going to be equivalent to the natural log of x is equal to y. So remember, the logarithm is equal to the exponent. So we're going to look at the base of the exponential e, and so that's going to be the natural log of the 2 to the x plus 5. It's going to be equal to the exponent on the e, which will be 4x minus 1. Then we're going to apply the power rule for logarithms. So if I have the natural log of r to the n, the power rule for logarithms allows us to bring down the power now as a factor. So we have r times the natural log of m. So we're going to bring down the x plus 5 as a factor times the natural log of 2. That's going to be equal to 4x minus 1. We're going to go ahead and use the distributive property, and we're going to distribute the x plus 5 to the natural log of 2. So that's just going to be x natural log of 2 plus 5 natural log of 2. That's going to be equal to 4x minus 1. And we have x on both sides of the equation, so we just need to pick one side to move all the x's to, and then everything else to the other side. So let's go ahead and subtract 4x from both sides. So it's going to move the x's to the left-hand side. So subtract from 4x from both sides. The 5 ln of 2 does not have a factor of x, so we're going to subtract that, and that's going to move it to the right side of the equation. So minus 5 ln of 2 minus 5 ln of 2. So then we're going to have x ln of 2 minus 4x. They're not like terms, we can't combine them. And that's going to be equal to negative 1 minus 5 natural log of 2. We have a common factor of x on the left, so we'll factor that out. So it becomes x natural log of 2 minus 4, and that's going to be equal to negative 1 minus 5 natural log of 2. Okay, we'll go ahead and come back on up here to the upper right-hand corner and finish solving. So we have x times the quantity natural log of 2 minus 4, and that's going to be equal to negative 1 minus 5 natural log of 2. And we'll go ahead and divide both sides by the natural log of 2 minus 4. So we'll have x is equal to negative 1 minus 5 natural log of 2 divided by the natural log of 2 minus 4. Okay, so there's our exact form. If we punch this into our calculators, but not too hard, we're going to get 1.3504 if we round to 4 decimal places. If you're going to put this into a TI 30x2s or something similar to that, you're going to need parentheses around the numerator, negative 1 minus 5, and then when you hit the natural log button, the ln button, you're going to get another parentheses. Put the 2 in, close the parentheses for the numerator. Then for the denominator, you'll need a parentheses, natural log of 2 minus 4, and then close your parentheses. Okay. This is probably going to be the simpler of the forms here, and so we ultimately want to get to base 10 or base e, because that's what most of our calculators will be able to handle. Some calculators are fancy enough to do bases other than e. Now, for the sake of rewriting in base 2, let's go ahead, log base 2, let's go ahead and look at the same problem here. And so now we're going to rewrite, if we have 2 to the y power is equal to x, that's equivalent to log base 2 of x, and that's going to be equal to y. So this one's going to be a little bit more work. So we're going to have log base 2 of e to the 4x minus 1, and that's going to be equal to the exponent on the 2, which is x plus 5. We're going to go ahead and employ the power rule here. So log base 2 of m to the r, that's going to be equal to r times log base 2 of m. So the exponent becomes a factor. So the exponent is 4x minus 1. That becomes a factor of log base 2 of e. And that's going to be equal to x plus 5. We're going to go ahead and distribute on this one also. So a very, very similar method of solution here. So 4x times log base 2 of e will be 4x log base 2 of e. And then negative 1 times log base 2 of e will just be negative log base 2 of e. And that's going to be equal to x plus 5. And then we need all the x's on one side of the equation. So let's go ahead and move them to the left. So we're going to subtract x from both sides of the equation. And then the log base 2 of e, the minus log base 2 of e, doesn't have a factor of x. So we're going to go ahead and add that to both sides. So we're going to move it to the right-hand side. So plus log base 2 of e, plus log base 2 of e. And so we're going to have 4x log base 2 of e plus x, sorry, not plus x, subtracting x. And that's going to be equal to 5 plus log base 2 of e. We're going to factor an x out of the left-hand side, so we'll have x times the quantity 4 log base 2 of e minus 1, and that's going to be equal to 5 plus log base 2 of e. Okay, we'll go ahead and send this up to the upper right-hand corner. And so what we'll do here in just a moment is we'll divide both sides by the factor of 4 log base 2 of e minus 1. So divide by 4 log base 2 of e minus 1. Divide by 4 log base 2 of e minus 1. So x is equal to 5 plus log base 2 of e divided by 4 log base 2 of e minus 1. And so this is the answer. That's the exact answer, but we may not be able to put that into our calculator if our calculator doesn't do base 2. So we can use the change of base formula. Log base b of x is equal to the natural log of x divided by the natural log of b. And you could use common log here, just replace the natural log with common log. It'll work out the same. All right, so we have 5 plus the natural log of e divided by the natural log of 2 divided by 4 times the natural log of e divided by the natural log of 2 minus 1. And then we'll recall that e and the natural log are inverses, so the ln of e is just going to be, well, it's going to be the exponent. The exponent here is going to be 1. Okay. All right, so this is going to be 5 plus 1 over the natural log of 2 divided by 4 divided by, well, it'll be 4 divided by the natural log of 2, or 4 times 1 over ln 2, minus 1. All right. And we'll continue this on to the next page just to clean it up a little bit. There's our change of base formula. Okay. All right. So here's what we got. All right. We're going to go ahead and clear the fractions. We're going to multiply the numerator and the denominator by the natural log of 2. All right, so that's going to be 5 times the natural log of 2. And then natural log of 2 times 1 over natural log of 2 will be the natural log of 2 over the natural log of 2, divided by 4 natural log of 2 divided by natural log of 2, and then minus natural log of 2. So we'll reduce, and this is going to be 5 natural log of 2 plus 1 over 4 minus the natural log of 2. Okay, and this will be approximately 1.3504. Okay, in our calculator, this would be 5 natural log of 2 plus 1 parentheses and parentheses 4 minus natural log of 2 close parentheses, close parentheses. Okay. Now, if I take this expression, 5 ln of 2 plus 1 over 4 minus natural log of 2, and I multiply it by negative 1 over negative 1. So that doesn't change anything, just changes how it looks. So this would be negative 5 ln of 2 minus 1 divided by negative 4 plus the natural log of 2. And so I think in the other, when we were solving this a moment ago, we got negative 1 minus 5 ln of 2 over ln of 2 minus 4. So it is an equivalent answer, just looks a little bit different. Okay. All right, let's go ahead and solve this one more time for fun. This time we're going to apply the natural log of both sides and use the power rule. All right, so here's our function here, and so we're going to take the natural log of both sides of the equation. Okay, you could also do this. You would do this with either the natural log or the common log, or most common that we're going to do here. You can do this with any logarithm. It's just you pick on base 10 and base e because that's what your calculator has. So we apply the natural log to both sides of the equation here, and we got something nice because we have the natural log of e. So natural log of e to the x is just equal to x. It's the inverse property there of a function and its inverse. So that frees the 4x minus 1. Then on the natural log of 2 to the x plus 5, we're going to apply the power rule, which brings down the x plus 5. The exponent becomes a factor times the natural log of 2. Okay, and then we're going to distribute the x plus 5 to the natural log of 2. So x times the natural log of 2 plus 5 times the natural log of 2. And we got x's on both sides of the equation, so we're going to go ahead and subtract 4x from both sides. Okay, and we're going to subtract 5 natural log of 2 from both sides of the equation here. And this is going to get all the x's on the right-hand side of the equation here. So you have negative 1 minus 5 natural log of 2, and that is going to be equal to x natural log of 2 minus 4x. Okay. So on the right-hand side, we'll factor an x out. So we'll have x and then natural log of 2 minus 4. Okay, and then we'll come on up and we have minus 1 natural log, minus 5 natural log of 2 is equal to x times the quantity natural log of 2, and then minus 4. And then we'll divide both sides by the natural log of 2, and then minus 4. Okay. All right, so x is equal to negative 1 minus 5 natural log of 2 divided by the natural log of 2 minus 4. And so x is going to be equal to about 1.3504, okay? And so if we could do this same problem again, taking the regular common log of both sides, but we've probably done more than enough for this problem here. So I think we'll stop here, and we'll see you next time.